Alright, let's walk through a simple problem together. The question says 0.92 into 10 to the power 16 electrons pass through a wire in 50 milliseconds. We need to figure out the current. First, let's visualize what's going on. If we consider a cross section of the wire, then over the span of 50 milliseconds, 0.92 into 10 to the power 16 electrons are passing through that section. But here's something to be noted. The problem doesn't directly tell us how much charge has passed through the wire. It just gives us the number of electrons. But we know that each electron carries a charge of minus 1.6 into 10 to the power minus 19 coulomb, which we usually represent as minus E. So to find the total amount of charge that passed through the wire, we just multiply the number of electrons by the charge of a single electron. That gives us 1.472 into 10 to the power minus 3 coulomb. Now notice that we are ignoring the negative sign of the charge. That's because the negative sign just tells us that the current flows in the opposite direction to the flow of electrons, which we have already covered in a previous video. Next, to find the current, we use the formula I equals to Q by T, where Q is the total charge we just calculated and T is the time, which in this case is 50 milliseconds. So plugging the numbers in, we get the current 29.44 milliampere. And since electrons are flowing from left to right, the current will be flowing in the opposite direction, from right to left. And that's it. Pretty straightforward, right? In the next video, I'll work through a slightly difficult problem. One more word before leaving. If you need any help or just want to support this channel, please become a Patreon member, where you will also find solutions to selective exercise problems like this one. See you there.